Did you know there are snails that spend their entire lives swimming or drifting in the ocean and never touching the bottom? Instead of crawling over reefs, rocks, and kelp, their muscular foot has evolved into a pair of wings, allowing them to take advantage of the Earth's largest habitat, the open waters between the sea's surface and bottom. Pteropoda, the Latin name for these snails, means wingfoot. They are planktonic animals, so they are carried along by ocean currents. The pteropods are a widespread and diverse group and play an important role in the oceanic food web. There are two distinct types of pteropods: those with thin, lightweight shells and those that have completely lost their shells. The shelled pteropods produce a net of sticky mucus to trap marine snow, material made of dead plant and animal remains, fecal matter, sand, and dust that falls from shallower water. These particles are constantly sinking through the water column, and there is still plenty of nutritious material contained in them. The ability to passively collect your next meal in a drifting net is a great energy-saving adaptation to living in the open ocean. On the other hand, the pteropods without shells are all carnivorous and, as far as we know, feed solely upon shelled pteropods. They have sets of curved hooks and suckers or sticky tentacles that are tucked inside the head when they are not actively feeding. When they contact a shelled pteropod, these feeding structures come out to grasp and pull the prey out of its shell. We do not yet know how these pteropods locate their prey, though given that they don't have eyes, they likely use something akin to a sense of smell, or they swim around until they happen to bump into their favorite snack. Pteropod shells are made of calcium carbonate, the same material many marine organisms secrete to form shells, such as clams, or hard supportive skeletons, like corals. There are different ways to produce a calcium carbonate shell, and unfortunately for pteropods, their shells are very sensitive to changes in ocean chemistry. As the acidity of the ocean increases, the fragile pteropod shells are vulnerable to dissolving, challenging the health and growth of these species. This could spell bad news not only for pteropods, but also for the variety of animals, including fishes, sharks, squids, and marine mammals that eat them. The wide diversity of pteropods is a fascinating example of how animals can evolve to take advantage of a habitat where you would never expect to find them. This is Stephanie Bush at the Monterey Bay Aquarium Research Institute.